Hello there, welcome back to our channel. Today we're going to discuss a topic that has fascinated humans for centuries, the possibility of intelligent life on other planets. Are we alone in the universe? Let's find out. Let's talk about some points that can help us imagine whether it is possible for intelligent life to exist on other planets. First, the Drake equation. Named after astronomer Frank Drake, who developed it in 1961, is a mathematical formula used to estimate the number of communicative civilizations that might exist in the Milky Way galaxy. It takes into account factors such as the rate of star formation in the galaxy, the fraction of stars that have planets, the number of planets that are suitable for life, the fraction of those planets where life actually emerges, and the fraction of those that eventually develop intelligent civilizations capable of communicating across space. The Drake equation is not a definitive answer to the question of whether there is intelligent life elsewhere in the universe, but it provides a framework for thinking about the problem in a systematic way. The equation suggests that the number of communicative civilizations in our galaxy could be anywhere from a few to millions, depending on the values we plug in for each of the parameters. One of the challenges of the Drake equation is that many of the parameters are uncertain and difficult to estimate accurately. For example, we don't yet know how common it is for life to emerge on planets or how likely it is for intelligent civilizations to develop. Nevertheless, the equation has been a useful tool for stimulating scientific discussion and research into the possibility of extraterrestrial life. Second, the Kepler telescope. The Kepler telescope was a NASA spacecraft launched in 2009 with the primary mission of discovering exoplanets, or planets outside of our solar system, particularly those that are in the habitable zone of their host star. The habitable zone, also known as the Goldilocks zone, is the region around a star where the conditions are just right for liquid water to exist on the surface of a planet. This is considered an important criterion for the potential habitability of a planet because water is essential for life as we know it. Over its mission lifetime, the Kepler telescope discovered thousands of exoplanets, including many that are in the habitable zone of their star. While most of these planets are not Earth-like, meaning they have different sizes, compositions, and atmospheric conditions, they still represent a significant milestone in our quest to understand the diversity of planets in the universe. The discovery of so many exoplanets, particularly those in the habitable zone, has also increased the possibility of finding life elsewhere in the universe. While we have not yet detected signs of intelligent life on any of these planets, the fact that they exist and may have conditions suitable for life raises exciting prospects for future research and exploration. Third, Fermi Paradox. The Fermi Paradox is the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of evidence for, or contact with, such civilizations. Named after physicist Enrico Fermi, who first posed the question in 1950, the paradox is often expressed as the question, where is everybody? The paradox is based on the assumption that there are many habitable planets in the universe and that some of them must have developed intelligent life capable of interstellar communication and travel. One possible explanation for the Fermi paradox is that intelligent civilizations may be too far away from us to detect or communicate with. Even with our most advanced technology, we can only scan a small fraction of the galaxy for signs of life, and the distances between stars and planets are vast. Additionally, it's possible that other civilizations may not be interested in communicating with us or may be communicating in ways that we don't yet understand. Another possible explanation for the Fermi paradox is that the development of intelligent life may be much less likely than we originally thought. While the existence of Earth-like planets in the habitable zone of stars has been established, we still don't know how often life emerges on such planets, or how often it evolves into intelligent life capable of space travel. Overall, the Fermi paradox remains one of the most intriguing and enduring mysteries in science, and it continues to drive research and exploration in the search for extraterrestrial life. Fourth, radio signals. The search for extraterrestrial intelligence, SETI, is a collective term for scientific efforts to search for signs of intelligent life beyond Earth. SETI research involves a variety of methods, including using radio telescopes to search for patterns or signals that may indicate the presence of intelligent beings, analyzing data from the Kepler telescope to identify potentially habitable planets, and searching for biosignatures, or signs of life, in the atmospheres of exoplanets. One of the most famous SETI projects is the SETI Institute's Allen Telescope Array, which consists of a network of radio telescopes located in Northern California. The array is designed to scan the sky for narrow-bandwidth radio signals that may be of artificial origin, indicating the presence of intelligent life. Another SETI project is Breakthrough Listen, a $100 million initiative launched in 2015 that uses some of the world's most powerful telescopes to search for signs of intelligent life in the Milky Way galaxy and beyond. Breakthrough Listen also collaborates with SETI projects around the world to share data and resources. While no definitive evidence of extraterrestrial intelligence has been found yet, SETI research continues to push the boundaries of our understanding of the universe and raises important questions about the nature of life and intelligence in the cosmos. In conclusion, the possibility of intelligent life on other planets is a fascinating and complex topic that has been the subject of scientific research and speculation for many years. While we still don't have a definitive answer to the question of whether there is intelligent life elsewhere in the universe, there are several factors that suggest that the possibility is not as remote as we once thought. The Drake equation provides a framework for estimating the number of communicative civilizations in our galaxy, while the Kepler telescope has discovered thousands of exoplanets, some of which are in the habitable zone of their star. The Fermi Paradox, on the other hand, highlights the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of evidence for their existence. Despite the challenges involved in detecting and communicating with extraterrestrial civilizations, the search for extraterrestrial intelligence, SETI, continues to push the boundaries of our knowledge and understanding of the universe. Whether or not we ever find definitive proof of intelligent life beyond Earth, the search for extraterrestrial life is an important and inspiring endeavor that reminds us of the vastness and complexity of the universe we live in.